Now that we understand the objectives and strategy for introducing AI-based buses in the city, the next step is to identify the data we need for analysis. To make informed decisions about the AI bus system, we've outlined 7 ideal datasets. These datasets will help us monitor bus usage, track driver shortages, evaluate performance, and understand public sentiment. However, I want to stress that these datasets are ideal. Not all of them need to be collected immediately or even at all. They provide a complete picture, but they are not mandatory for the success of this project. Let's walk through each dataset and its key features. 1. Bus usage and passenger data. This dataset combines information about bus usage and passenger demographics. It helps us understand how often the buses are used and by whom. Key features. Route ID. Each bus route has a unique identifier. This allows us to track the performance of specific routes. Daily passenger count. This tells us how many passengers are using each bus route on a daily basis. Bus capacity utilization. We'll look at the percentage of seats occupied to see if buses are overcrowded or underused. Time of day. We'll identify peak versus non-peak hours to understand demand patterns. Passenger type. We'll break down passengers by age group, focusing on elderly and disabled riders to ensure accessibility needs are being met. 2. Driver data. Next, we have the driver data, which is critical for understanding the root of the driver shortage and how AI buses might alleviate this problem. Key features. Driver ID. Each driver is assigned a unique identifier so we can track their activity. Assigned routes. We'll know which routes each driver is responsible for, allowing us to connect driver performance to specific routes. Unfulfilled shifts. This metric is crucial. It shows us how many driver shifts are left unfilled, which leads to disruptions in bus services. Overtime hours. We'll track overtime to understand the workload and whether drivers are overworked. Driver satisfaction. Through surveys, we'll assess how satisfied the drivers are with their working conditions. High dissatisfaction could be contributing to the shortage. 3. Bus performance and AI system data. This dataset combines performance data from both traditional buses and AI buses. It allows us to compare their effectiveness. Key features. Bus ID. Every bus, whether AI-based or not, will have a unique identifier for tracking. Miles covered. This tells us how much distance each bus covers on a daily basis, helping us evaluate efficiency. Service delays. We'll monitor any delays in service to determine whether AI buses are reducing or contributing to delays. Fuel efficiency. Comparing fuel or electricity consumption between AI and non-AI buses helps us evaluate operational costs. AI system downtime. We need to track how often the AI system goes offline or needs manual intervention. This is crucial for assessing reliability. 4. Traffic and external factors data. External factors like traffic and weather conditions can impact bus performance, and we need this data to get a full picture. Key features. Traffic congestion. We'll monitor congestion levels during peak and non-peak hours, which can impact bus delays. Accident data. We'll track any accidents that could affect bus routes and delay services. Weather conditions. Weather data is crucial, especially during challenging conditions like rain or fog, which could affect both AI and traditional buses. Road closures. Knowing when and where road closures happen will help us evaluate how they impact bus performance. Visibility conditions. This is particularly important for AI buses, as poor visibility could affect their performance. 5. Economic data. We need to understand the costs and potential savings of implementing AI buses, and this dataset will track all economic factors. Key features. Bus maintenance costs. We'll compare the maintenance costs for AI and non-AI buses. Driver salary data. This gives us insight into the costs associated with employing drivers and helps estimate potential savings from reducing driver shortages. Fuel and energy costs. We'll track the costs of fuel for traditional buses and electricity for AI buses to see if AI buses are more cost-effective. Initial AI bus investment. This is the upfront cost of purchasing and implementing AI buses. Operational savings. By reducing driver shortages and improving efficiency, we can estimate how much the city might save over time. 6. Safety and incident data. Public confidence in AI buses will depend on their safety. This dataset captures all safety-related data. Key features: number of incidents. We'll track the number of incidents, such as accidents or mechanical failures, for both AI and non-AI buses. Incident type. Categorizing incidents helps us understand whether the issues are related to technology, human error, or other factors. Passenger safety ratings. We'll gather passenger feedback on how safe they feel while riding AI buses. Manual interventions. We need to know how often human operators have to take over AI buses to maintain safety. System downtime due to safety. If AI buses are taken offline due to safety concerns, we need to track how often this happens. 7. Public sentiment and feedback data. Lastly, we need to understand how the public perceives AI buses. This dataset will focus on passenger and community feedback. Key features: satisfaction ratings. Overall satisfaction from passengers using AI buses will be tracked. Complaints filed. Monitoring complaints will help us identify recurring issues and areas for improvement. Public opinion polls. We'll gather general feedback from both bus users and non-users to understand how AI buses are being perceived. Accessibility feedback. We'll focus on feedback from elderly and disabled passengers to ensure the buses are meeting their needs. Community engagement data. Feedback from public forums and town hall meetings will provide a broader sense of how the community feels about the AI bus system. However, note that the city can only prepare the datasets that are circled to keep the data science project simple.